So this video is going to talk about the cosine parent function and how to analyze that. So I want to take you back to your unit circle, and keep in mind with the unit circle we start at 0, okay, and that is located at the coordinates 1, 0. And as you work counterclockwise around that unit circle and you go one revolution around, when we go 90 degrees, which is pi over 2, we get the point 0, 1. When we go to another 90 degrees, or another pi over 2, we get pi, and it's located at negative 1, 0. Another pi over 2 gets us to 3 pi over 2, and it coordinates with the point 0, negative 1, and then we get to 2 pi. And so that is one cycle around the circle. And one cycle around the circle is called a period. So if I go one time around that unit circle, that period is going to be 2 pi. Let's fill in this table to evaluate the cosine of x. So if I start at, say, 0, and I'm looking at the cosine of 0. Well, the cosine of 0, when we go to 1, 0, the cosine is the x value, and that would be a 1. And then if we rotate and go to pi over 2, and pi over 2 in a decimal we have learned is 1.57, that x value is 0. And then if we go to pi, which is 3.14, that x value is negative 1. Another pi over 2, we're at 3 pi over 2, and we have learned that that decimal is 4.71, and its x value is at 0. Okay. And finally, all the way around the circle, which is 2 pi, is going to be 6.28, and its x value is 1. So when I do one cycle, one revolution around that circle, the cosine function is basically using those quadrantal angles and graphing the x-coordinates. So here's what I notice. I have the point 0, 1. So I'll make this 1 and this negative 1. And that will make this 1, 2, 3, 4, 5, 6, 7. Okay, so here is our graph. We're going to plot 0, 1. And then we're going to plot 1.57, 0. 3.14, negative 1, 4.71, 0, and then 6.28, 1. This represents your cosine function. One revolution around that unit circle. So if this is at 2 pi, the period is 2 pi. That means I should see one cosine function every 2 pi. Okay. Let's go ahead and analyze this cosine function. Let's take a look at it. The domain for the cosine function is all real numbers. So in other words, negative infinity to infinity. The range, well, the range goes from including negative 1 to including 1. Is it continuous? Meaning, if I use my pencil and trace it, do I lift up my pencil? I do not. Therefore, yes, it's continuous function. There are no holes or breaks in the graph. The increasing interval, well, let's see. If I'm at 0, 1, I see that the graph goes down to pi, and then it goes back up. So it's increasing and decreasing. And I'm going to call that alternating on our waves. Alternating alternating on waves. So it's going to alternate the increasing and the decreasing. Does it have symmetry? Yes. Well, with respect to, it's going to be respectful to the y-axis. If it's respectful with respect to the y-axis, that means it's going to be an even function. Does it have extrema? Well, yes, it does. It has an absolute max at 1. And it has an absolute minimum at -1. So your wave is going to bounce between -1 and 1. Okay, it's going to alternate increasing and decreasing between those y values. Period over here, we've already talked about that. That's 2 pi. Vertical asymptotes, there aren't any. None. Horizontal asymptotes, there aren't any. So none. End behavior. As your function approaches negative infinity, this wave is just going to continue. So it's not going to necessarily have a limit, so it does not exist. And as x approaches infinity, that wave is going to continue to increase and decrease. So the limit does not exist. Okay? As we go from x approaches negative infinity and the limit as x approaches infinity. So that is our cosine function, which I'm going to then show you how to do some transformations using this parent function.